Next, law. So we are continuing with the work energy power chapter. Next, law of conservation of energy. Good evening, all of you. Good evening. Law of conservation of energy. Law of conservation of energy states that energy can neither be created nor be destroyed, but it can transform from one form to another. You cannot create energy or destroy energy, but can be transferred from one form to another. Total energy of a universe is a constant. There are two definitions. Energy can neither be created nor be destroyed. ഉണ്ടാക്കാനും പറ്റൂല നശിപ്പിക്കാനും പറ്റില്ല, but can be converted from one form to another. Or you can say total energy of the universe is a constant. Power. Power is defined as the rate of doing work. What is power? Rate of doing work. Power is a scalar quantity. Dimensions of power, we know that ml square t raised to minus 3. SI unit of power is watt. 1 kilowatt is what? 1000 watt. Kilowatt is the commercial unit of power. Commercial unit of power is what? Kilowatt. SI unit of power is what? Watt. 1 horsepower, British time. Its horsepower is a unit that is used in British time. 1 horsepower is equal to 746 watt. Now, what is the equation for instantaneous power? Limit delta t tends to 0, delta w by delta t or dw by dt. That is the equation for instantaneous power. I hope all of you remember instantaneous velocity. Instantaneous velocity equation is what? V vector is equal to limit delta t tends to 0, delta x by delta t. Instantaneous acceleration is what? Limit delta t tends to 0, delta v by delta t. That is instantaneous acceleration. Instantaneous acceleration. Instantaneous power, instantaneous velocity, instantaneous acceleration. Instantaneous power is what? Limit delta t tends to 0, delta w. It is not omega, here it is work done. So instantaneous power is equal to what? Limit delta t tends to 0, delta w by delta t, that is dw by dt. That is the equation for power. Note it down. എല്ലാവരും നോട്ട് ചെയ്യാം കേട്ടോ. എല്ലാവരും നോട്ട് ചെയ്യാം കേട്ടോ. ലോ ഓഫ് കൺസർവേഷൻ എനർജി, പവർ, SI unit of power, dimensional formula, instantaneous power, definition of power, what is the unit of power, watt, commercial unit of power, kilowatt or 1000 watt. ഒന്ന് മ്യൂട്ട് അടിച്ചേ. ഡൺ. നോട്ട് ചെയ്താ എല്ലാവരും നോട്ട് ചെയ്യടാ, വേഗം നോട്ട് ചെയ്യും. നോട്ട് ചെയ്ത് കഴിഞ്ഞാ നോട്ട് ചെയ്ത് കഴിഞ്ഞാൽ സ്റ്റുഡൻസ് പ്ലീസ് റെസ്പോണ്ട്. ഇവിടെ കുട്ടികളുണ്ടോ? ഒരു പോയാ? Done? Noted? So next, kilowatt hour. 1 kilowatt hour is the electrical energy consumed by an appliance of 1000 watt when it is used for in 1 hour. What is 1 kilowatt hour? It is the energy consumed by an appliance. Appliance means what? ഉപകരണം. മലയാളത്തിൽ ഉപകരണം എന്ന് പറയും. 1000 വാട്ട് കപ്പാസിറ്റി ഉള്ള ഒരു ഉപകരണം 1 മണിക്കൂർ യൂസ് ചെയ്യുമ്പോൾ എത്ര എനർജി കൺസ്യൂം ചെയ്യുന്നുള്ളതാണ് 1 കിലോവാട്ട് അവർ. അപ്പോൾ 1 കിലോവാട്ട് അവർ ഈക്വൽ ടു 1000 വാട്ട് ഇൻറ്റു 1 അവർ. 1000 വാട്ടിന് പകരം എന്ത് ചെയ്താൽ ജൂൾ പെർ സെക്കൻഡ് into 1 hour is what? 3600. So 1 kilowatt hour equal to how much joule? 3.6 into 10 raised to 6 joule. Kilowatt hour is the commercial unit of electrical energy. Commercial unit of power is kilowatt. Commercial unit of energy is what? Electrical energy is what? Kilowatt hour. 1 kilowatt hour equal to what? 3.6 into 10 raised to 6 joule. Power is dot product. What is power? Work done by time. So what is work done? Force into displacement by time. Displacement by time is what? Velocity. So power can be expressed as dot product as what? F vector dot V vector. Power equal to what? F vector dot V vector. So force vector dot velocity vector will give what? Power. നോട്ട് ചെയ്യാട്ടോ. നോട്ട് ചെയ്യാം. കിലോവാട്ട് അവർ ഇസ് commercial unit of electrical energy. Power is dot product. നോട്ട് ചെയ്താ? നോട്ട് ചെയ്താ? Next problem I will do it in the last. Yeah, next collisions. Next topic is collisions. Elastic collision. If the total, listen, first of all, in all type of collision, all type of collisions, total energy and total linear momentum are conserved. Total energy and total linear momentum are conserved in all type of collision. എല്ലാ കൊളീഷനിലും ആര് കൺസേർവ്ഡ് ആ? ടോട്ടൽ എനർജിയും ടോട്ടൽ ലീനിയർ മൊമെന്റും കൺസേർവ്ഡ് ആണ്. അത് എപ്പോഴും ശ്രദ്ധിക്കുക. ഇൻ ഓൾ ടൈപ്പ് ഓഫ് കൊളീഷൻ ടോട്ടൽ എനർജി ആൻഡ് ടോട്ടൽ ലീനിയർ മൊമെന്റ് ആർ കൺസേർവ്ഡ്. In elastic collision പ്രത്യേകത എന്താ? Total kinetic energy is also conserved, which means what? Total energy conserved, linear momentum conserved. In addition, elastic collision എന്തുകൂടി conserved? Kinetic energy കൂടി conserved ആണ്. Example, collision of subatomic particle is nearly elastic. Next is inelastic collision. Total kinetic energy is not conserved during a collision, then the collision is said to be what? Inelastic collision. Collision of example for inelastic collision between vehicles, collision between pebble എന്ന് പറഞ്ഞാൽ വെള്ളാരും കല്ലുകൾ കൂട്ടിയിടിക്കുമ്പോൾ collision. നമ്മളെ ഡേ ടു ഡേ ലൈഫിൽ കാണുന്ന all collisions are inelastic collision. Almost all collision in nature are what? Inelastic. The total energy and total linear momentum are conserved during all type of collision. In all type of collision, total energy and total linear momentum are conserved. Note here. Note here. In all type of collision, total energy, total linear moment are conserved. Elastic collision, kinetic energy is conserved. Example for elastic collision in subatomic particle within the atom. Then collision, example for inelastic collision, day-to-day life collision. What is the specialty of inelastic collision? Kinetic energy not conserved. Note here. Note here. Then next, elastic collision is one dimension. It's a very lengthy derivation, so I will do it separately. Elastic collision in one dimension. It's a lengthy derivation. Let's see elastic collision one dimension. Consider two masses m1 and m2 moving along a straight line. Moving along a straight line. Moving along a straight line with the velocities u1 and u2 collide elastically collide elastically with each other. And velocities changes to V1 and V2. So first body of mass M1, initial velocity U1. Second body of mass M2, initial velocity U2. This is before collision. Now this photo is taken during collision, M1, M2. Then after collision, what happens? First body M1 moves with velocity V1, second body M2 moves with velocity V2. Now this is what? During collision, and this figure after collision. Now, since linear momentum is conserved, what is linear momentum is conserved? It's a separate topic. Law of conservation of linear momentum. I'm choosing another color because it is a separate topic. Law of conservation of linear momentum states that total momentum after collision is equal to total momentum before collision. Total momentum before collision. So, what happens? M1 U1 first body momentum plus M2 U2 is equal to what? M1 V1 plus M2 V2. So, M1 U1 minus M1 V1 is equal to what? M2 V2 minus M2 U2. So, M1 into U1 minus V1 is equal to what? M2 into V2 minus U2. Since collision is elastic, kinetic energy is also conserved. So total kinetic energy before collision is equal to total kinetic energy after collision. Total kinetic energy before collision is what? Half M1 U1 square plus half M2 U2 square is equal to what? Half M1 V1 square plus half M2 V2 square. So, half M1 U1 square minus half M1 V1 square is equal to what? Half M2 V2 square minus half M2 U2 square. So, half M1 U1 square, sorry, not only half, I am taking half M1 outside, half M1 outside. So, U1 square minus V1 square is equal to what? Half M2 taken outside this side, V2 square minus U2 square. So half gets cancelled. So M1 into u1 square minus v1 square is equal to m2 into v2 square minus u2 square. Now we know that a plus b into a minus b is equal to a square minus b square. So m1 into u1 plus v1 into u1 minus v1 is equal to m2 into v2 plus u2 into v2 minus u2. അത് ക്ലിയർ ആയി വരികയും Now I am considering this as equation 2 and m1 into u1 minus v1. What a ചെറിയ mistake ഉണ്ട്. m1 into u1 minus v1 ഇവിടെ m1 പുറത്തേക്ക് എടുക്കുമ്പോൾ u1 minus v1 ആണ് is equal to m2 into v2 minus u2. This is equation 1. So I got equation 2 and 1. So equation 2 divided by equation 1. So m1 into u1 plus v1 into u1 minus v1 is equal to m2 into v2 plus u2 into v2 minus u2 all divided by, that is equation 2 divided by, what is equation 1? m1 into u1 minus v1 is equal to m2 into what? v2 minus u2. What happens? m1 gone, u1 minus v1 cancel ചെയ്തു, v2 minus u2 m2 f2 cancel ചെയ്തു. So what you are getting? u1 plus v1 is equal to v2 plus u2. That is u1 minus u2 is equal to what? v2 minus v1. That is u12. u1 minus u2 can be written as u12. v2 minus v1 can be written as v21. So what is the concept here? What is the concept we got? What is the meaning of this? Initial. U means what? Initial velocity. u12 means initial velocity of first body with respect to second body is equal to final velocity of second body with respect to first body. That is initial velocity of first body with respect to second body is equal to final velocity of initial velocity of first body with respect to second body it is before collision is equal to final velocity of second body with respect to first body after collision. Second body with respect to first body after collision. See, the derivation is not done, not finished. So what is the final answer we got? What is the equation we got? I am taking this equation to the next step. u1 plus v1 is equal to v2 plus u2. u1 plus v1 is equal to v2 plus u2. Put this so what is v2? v2 is equal to u1 plus v1 minus u2. Put v2 in equation number 1. What was equation number 1? m1 into u1 minus v1 m1 into u1 minus v1 is equal to m2 into v2 minus u2. m1 into u1 minus v1 is equal to m2 into v2 minus u2. Here, instead of v2, I can write what? m1 into u1 minus v1 is equal to m2 into, instead of v2, I can write what? u1 plus v1 minus u2 minus u2. So, m1 into u1 minus v1 is equal to m2 u1 plus m2 v1 minus m2 u2 minus m2 u2. That is m1 u1 minus m1 v1 is equal to m2 u1 plus m2 v1 minus 2 m2 u2 minus 2 m2 u2. Now I am taking one side and two other side. So m1 u1 plus m2 u1 plus 2 m2 u2 is equal to what? m2 v1 plus m1 v1. Minus m1 v1 goes to other side, it becomes plus m1 v1. Minus 2 m2 u2 coming to the left hand side, it becomes plus 2 m2 u2. So if you take u1 common, u1 into m1 plus m2 plus 2 m2 u2 is equal to v1 into m1 plus m2. So what will be v1? v1 is equal to u1 into m1 plus m2 plus 2 m2 u2 divided by m1 plus m2. This is the equation for final velocity in elastic collision in one dimension. Similarly, you can find out v2. v2 കാണാൻ ഒരു ബുദ്ധിമുട്ടുമില്ല. Just by heart equation for v1 and change each 1 to 2. 1 2 ആക്കുക, 2 ആണോടത്ത് 1 ആക്കുക. So v2 is equal to what? u2 into m2 minus m1 plus 2 m1 u1 divided by m1 plus m2. This is equation for v2. Equation for v1. v2 is equal to 2 m1 u1 plus u2 into m2 minus m1 divided by m1 plus m2. v1 is equal to u1 into m1 plus. Now there is a mistake. m1 u1. No, there is a small mistake here. m1 u1 minus m2 u1. So u1 into m1 minus m2. u1 into m1 minus m2. u1 into u1 is taken common. m1 u1, this m2 u1 coming to left hand side, it becomes what? Minus m2 u1. Then taking u1 common, m1 minus u1 into m1 minus m2. There is a mistake from my side. m2 u1 coming to the left hand side, it should become minus m2 u1. ആ തിരുത്ത് ഞാൻ ചെയ്തിട്ടുണ്ട്. കറക്ഷൻ ഉണ്ട്. m2 u1 coming to this side, it becomes minus m2 u1. So u1 taken common. So u1 into m1 minus m2. Any doubts? ഇനി ഇത് ആദ്യം തൊട്ട് എഴുതിയെടുക്കണം കേട്ടോ. എല്ലാവരും കമ്പൽസറി ആയിട്ട് ഇപ്പൊ തന്നെ എഴുതിയെടുക്കണം. ഇത് വളരെ ഇമ്പോർട്ടന്റ് ഡെറിവേഷൻ ആണ്. എഴുതിയെടുക്കണം. നോട്ട് ചെയ്യാട്ടോ, സ്റ്റെപ്പ് ബൈ സ്റ്റെപ്പ് നോട്ട് ചെയ്യാം. സ്റ്റെപ്പ് ബൈ സ്റ്റെപ്പ് നോട്ട് ചെയ്യാട്ടോ. നോട്ട് ചെയ്യാം. ഇവിടം വരെ എഴുതി കഴിഞ്ഞാൽ പിന്നെ ഇവിടെ നിന്ന് തുടങ്ങിക്കോളൂട്ടാ. ഇങ്ങനെ പോണേ, ഇങ്ങനെ എഴുതിയിട്ട് ഇങ്ങനെ വന്ന് പിന്നെ ഇങ്ങനെ എഴുതിക്കോളും. ഇക്വേഷൻ 1 ഇക്വേഷൻ 2 നോട്ട് ചെയ്യേണ്ടതാണ്. നോട്ട് ചെയ്യുക, സ്റ്റെപ്പ് ബൈ സ്റ്റെപ്പ് നോട്ട് ചെയ്യുക കേട്ടോ. അവിടെ വരെ കഴിഞ്ഞാൽ പിന്നെ ഇവിടെ നോട്ട് ഇക്വേഷൻ 2 ബൈ ഇക്വേഷൻ 1. ഈ സൈഡ് കഴിഞ്ഞു. Then നമ്മുടെ final equation V2, putting V2 in equation 1, we will get this derivation. Putting value of V2 in equation 1. Then we are solving for V1, and after getting the equation for V1, we are changing every 1 with 2 and every 2 with 1, then we will get V2. U1 equal to V1 equal to, here also there is a change, M1 minus M2, M1 minus M2 plus 2M2 U2 divided by M1 plus M2. V1 equal to U1 into M1 minus M2. My equation change in V1 equal to U1 into M1 minus M2 plus 2M2 U2 divided by M1 plus M2. V1 ഇവിടെ നിർത്തിയിട്ട് M1 plus M2 അടിയിലേക്ക് കൊണ്ടുവന്നു. So V1 equal to U1 into M1 minus M2 plus 2M2 U2 divided by M1 plus M2. India V1 equal to U1 into M1 minus M2 plus 2M2 U2 divided by M1 plus M2. P2 is equal to U2 into M2 minus M1 plus 2 M1 U1 by M1 plus M2. I hope all of you have completed. Now consider V1 is equal to, what is the equation? U1 into M1 minus M2 plus 2M2 U2 divided by M1 plus M2 divided by M1 plus M2. Similarly, V2 is equal to U2 into M2 minus M1 plus 2 M1 U1 divided by M1 plus M2. Now special cases. If colliding bodies have equal masses, that is M1 equal to M2 is equal to M. So V1 is equal to what? See, M1 minus M2 equal masses. So this term gone. So 2 M U2 divided by M plus M. that is 2m. So V1 is equal to U2. Then V2 is equal to equal mass. So the masses get cancelled here. 2m U1 divided by 2m. So what? V2 is equal to U1. That is final velocity of first body after collision is equal to what? Initial velocity of second body. And final velocity of second body after collision is equal to what? Initial velocity of first body. So what happened? Final velocity of first body is equal to initial velocity of second body. Final velocity of second body is equal to initial velocity of first body. That is, the two bodies will exchange their velocities. What we are discussing, chapter name is work energy power, topic name is collision. We are discussing elastic collision in one dimension. So special case 1 is done. Now special case 2. Case 2. Colliding bodies have equal masses and second body is at rest. So what does it mean? Equal mass means what? M1 equal to M2 equal to M. And the second body U2 final velocity, initial velocity is what? 0, because second body is at rest. This situation is similar to a carom board in which we are striking a coin with another coin, not with the striker. We are striking a carom board coin with another coin. So both coins have what? Same mass. And the second body is at rest. So what happens to the velocity of the first body? So what is situation? Second body of mass m is at rest, so u2 equal to 0. First body of mass m moving with the velocity v1, moving with the velocity u1. So what happens to velocity of the first body after collision? Equal mass, so m1 minus m2 gets cancelled. Second body is at rest, so u2 0, whole term becomes 0. That is, first body comes to rest. That is, after collision, first body comes to rest. After collision, first body comes to rest. Now what happens? V2 is equal to what? This term equal masses will cancel. So 2m u1 divided by 2m. So what happens? V2 equal to 1. That is, second body moves with the initial velocity of first body. Initial velocity of first body. Second body moves with the initial velocity of first body. Any doubt? Doubt enough? Arun Chand. My name is Lindo. Linto. Lindo. നോട്ട് ചെയ്തൊന്ന് നോട്ട് ചെയ്യാട്ടോ, വേഗം നോട്ട് ചെയ്യാം. So case 2, I hope all of you done. Next, case 3. Case 3. Mass of first body much greater than mass of second body, and second body is at rest. So initial velocity of second body is 0. So V1 equal to what? You can expect an example. A railway track, a train is coming, and a person is standing in the railway track. So mass of second body is what? Almost 0 as compared to mass of the train. This is train having mass m1. This is person mass m2, which is almost 0, and this person is at rest, and train is moving with the velocity v1. Sorry, velocity u1, initial velocity. So what will be the velocity of the train after hitting the person? m1 u1. Second person is at rest, so u2 0, so whole term becomes 0. m2 is 0, so m1 u1 by m1, m2 is 0. So what happened? m1 gets cancelled, v1 equal to u1. So when a massive body collides with a stationary small body, the final velocity and initial velocity is same. Train ആളെ ഇടിച്ചത് അറിഞ്ഞിട്ടില്ല, കാരണം ട്രെയിനിന്റെ ഇനീഷ്യൽ വെലോസിറ്റി ഫൈനൽ വെലോസിറ്റി സെയിം ആ. ഇനി what happens to the second body, that is the person standing on the railway track? u2 0, so whole term becomes 0. So 2m1 u1 divided by m1, m1 gets cancelled, v2 equal to what? 2u1. So second body moves with twice the initial velocity of first body. I will write the statement here. The second body moves with 2 times the initial velocity of the first body. 2 times initial velocity of the first body. 2 times the initial velocity of the first body. Second body moves with 2 times initial velocity of the first body. Now case 4. Case 4. There is a very massive second body. Suppose there is a big rock with mass m2 and u2 equal to 0, and very light body m1 moves with the velocity u1. So m1 mass is what? Almost 0. So light body with the mass m1 and initial velocity u1 is colliding a heavy body of mass m2 and initial velocity 0. So what happens to the light body v1 after collision? u2 is 0, so this term gone. m1 is 0, so minus m2 u1 by m2. m2 gets cancelled. v1 is equal to what? Minus u1. So why by minus sign? Because first body after hitting this massive body moves with the opposite, same magnitude but opposite direction. That is the reason why V2 is equal to minus U1. Now what happens to the massive body after collision? U2 0, M1 is 0. So V2 at heavy body remains again at rest. മനസ്സിലായോ? മാഷ് ഓടിച്ചെന്ന് ഒരു വലിയ പാറക്കല്ലുമ്മ പോയി ഇടിച്ചു. എന്താ ഉണ്ടാവുക? ഞാൻ അതേ വെലോസിറ്റി ബട്ട് ഓപ്പോസിറ്റ് ഡയറക്ഷനിൽ തെറിക്കും. എന്റെ ഫൈനൽ വെലോസിറ്റി ഇനി പാറക്കല്ലിന് എന്തുണ്ടാവും? അത് റെസ്റ്റിൽ തന്നെ തുടരുകയും ചെയ്യും. ഡൗട്ട് ഉണ്ടോ? നോട്ട് ചെയ്യാം. നോട്ട് ചെയ്യാം കേട്ടോ. നോട്ട് ചെയ്യാം കേട്ടോ. perfectly inelastic collision. In this type of collision, kinetic energy is not conserved, and after collision, colliding bodies stick together and move as a single mass. അതായത് ചളി വാരി ചുമരുമ്പോ എറിഞ്ഞു, അപ്പൊ ചെളി ചുമരുമ്പോ സ്റ്റക്ക് ചെയ്ത് നിൽക്കും. അല്ലെങ്കിൽ ഒരു മരത്തിന്റെ കട്ടയമേ ബുള്ളറ്റ് കൊണ്ട് ഫയർ ചെയ്തു, ഗണ്ണുകൊണ്ട് ഫയർ ചെയ്തു. അപ്പൊ ബുള്ളറ്റ് മരത്തിന്റെ കട്ടയിൽ തങ്ങി നിന്ന് മരത്തിന്റെ കട്ടയും ബുള്ളറ്റും കൂടി ഒരൊറ്റ സിംഗിൾ മാസ് ആവും. അങ്ങനത്തെ കൊളീഷനാണ് നമ്മൾ എന്താ വിളിക്കണേ? പെർഫെക്റ്റ്ലി ഇൻഇലാസ്റ്റിക് കൊളീഷൻ. Then one point, in perfectly inelastic collision, there will be always loss in kinetic energy. Always loss in kinetic energy. There will be always loss in kinetic energy. In perfectly inelastic collision, there will be always loss in kinetic energy. There will be always loss in kinetic energy. നോട്ട് ചെയ്യാട്ടോ. നെക്സ്റ്റ്, deduce means derive. Deduce the expression for change in kinetic energy during perfectly inelastic collision. During perfectly inelastic collision. Perfectly inelastic collision. Perfectly inelastic collision. Now, by the law of conservation of linear momentum, m1u1 plus m2u2 is equal to what? m1v1 plus m2v2. Total momentum before collision is equal to total momentum after collision. So here m1u1 plus m2v2 But after collision, the colliding bodies stick together and move as a single mass. So, what is the total mass? m1 plus m2, and what is the common velocity? V. Because if you fire, there is a wooden box having mass m2 and there is a bullet of mass m1, initial velocity u1, here initial velocity u2. After collision, what happens? This bullet gets stuck into this wooden box. So what is the total mass? m1 plus m2. And what is the common velocity? V. I shouldn't be writing v1 or v2. So what is the common velocity equation? m1 u1 plus m2 u2 m1 u1 plus m2 u2 is equal to what? M2 u2 divided by m1 plus m2. This is the equation for common velocity. Now loss of kinetic energy. Loss of kinetic energy is equal to what? Delta K is equal to final kinetic energy. See, there will be always loss in kinetic energy. So I am doing initial kinetic energy minus final kinetic energy. What is the initial kinetic energy? Half m1 u1 square plus half m2 u2 square minus final kinetic energy will be what? What will be final kinetic energy? Half. What is the total mass after collision? m1 plus m2, that is the total mass, into what is the final velocity? Equation is what? m1 u1 plus m2 u2 divided by m1 plus m2, that is the final velocity that we have derived earlier, the whole square. So delta K is equal to, this is the equation for changing energy. After solving, after deriving, you don't have to show that derivation. After simplification, delta K is equal to half into m1 m2 divided by m1 plus m2 into u1 minus u2 the whole square. This is the equation for changing energy. Here it is u1 minus u2 the whole square. So whether u1 greater than u2, u2 greater than u1, you will get always a positive answer. Delta K will be always positive. That is, there will be always loss in kinetic energy. In what collision? In perfectly inelastic collision. Inelastic collision, there will be always loss in kinetic energy. In perfectly inelastic collision. വന്നു നമ്മളെ മച്ചാന്മാര് വന്നു. നോട്ട് ചെയ്യാട്ടാ, നോട്ട് ചെയ്യാം, എഴുതിയെടുക്കുക. നെക്സ്റ്റ് collision in 2 dimension. Collision in 2 dimension. Consider a mass m1 moving with the velocity u1 collides with another body of mass m2 which is initially at rest. So second body is initially at rest. After collision, both the bodies move in different direction. Okay. So this is first body m1, initial velocity u1, goes in the straight line and hits the second body m2, initial velocity 0. Now, after collision, first body moves with velocity v1 of mass m1, make an angle theta1 with the horizontal. So this will be what? This side will be what? This side velocity will be v1 cos theta 1. The velocity is solved into two rectangular components, and this side velocity will be what? v1 cos theta 2. This side velocity is what? Second body moves with the velocity v2, make an angle theta 2 with the horizontal. So this side will be what? v2 cos theta 2. This side will be what? v2 sin theta 2. ഇവിടെ ഞാൻ ഇത് തെറ്റാ. ഇത് v1 cos theta 1, then this will be what? v1 not cos theta 2, v1 sin theta 1. Initially ഇതൊക്കെ തെറ്റാണല്ലോ ഇത്. Initially at rest. So after collision, first body moves with the velocity v1, making an angle theta 1 with the horizontal. So this side is what? v1 cos theta 1. This side v1 sin theta 1. Second body moves with the velocity v2, making an angle theta 2 with the horizontal. So this side v2 cos theta 2, and the vertical component v2 sin theta 2. Any doubt? Is it doubt na? Figure doubt na? ഫിഗർ വേണമെങ്കിൽ ഒന്നുകൂടി വരയ്ക്കാം. എനിക്കൊരു തൃപ്തി കുറവ്. ഫസ്റ്റ് ബോഡി മാസ് m1, ഇനീഷ്യൽ വെലോസിറ്റി u1, അത് സെക്കൻഡ് ബോഡിയിൽ ഹിറ്റ് ചെയ്തു, മാസ് m2, അതിന് ഇനീഷ്യൽ വെലോസിറ്റി 0. ആഫ്റ്റർ കൊളീഷൻ ഫസ്റ്റ് ബോഡി m1 makes an angle theta 1 with the horizontal. So this will be what? V1 cos theta 1. This will be what? V1 sin theta 1. Similarly, second body of mass m2 moves with the velocity v2, make an angle theta 2 with the horizontal. So this will be what? V1 cos theta, sorry, not V1, V2 cos theta 2, and this will be what? V2 sin theta 2. I hope it is clear. Now, for conservation of momentum, along x direction, conservation of momentum along x direction. Along x direction, what is the momentum of first body? M1 U1. Second body momentum will be 0. Why? Because second body U2 is equal to 0. Second body is at rest. M1 U1 is equal to M1 V1 cos theta 1 plus M2 V2 cos theta 2. This is the conservation of momentum along x-axis. This is equation number 1. Now along y direction. Along y direction, vertical component initial velocity is 0. Along y direction, vertical component of velocity is 0 because motion is happening only along x direction. So along y direction, no vertical component. So vertical component of momentum along y direction is what? 0. Now this side what we have, momentum along y direction is what? M1 V1 sin theta 1 plus, instead of plus I am writing minus M2 V2 sin theta 2. Why minus sign? Because this is in the opposite direction. So minus M2 V2 sin theta 2 along y direction. For conservation of moment along x direction, M1 U1 equal to M1 V1 cos theta 1 plus M2 V2 cos theta 2. Along y direction, 0 equal to M1 V1 sin theta 1 minus M2 V2 sin theta 2. Why it is 0? Because before collision there is no momentum along y direction. Because there is no component of velocity in y direction. Motion happens only in x direction. Next, if collision is elastic, kinetic energy is also conserved. So what happens? Collision is elastic, kinetic energy is also conserved. So half m1 u1 square initial kinetic energy is equal to half m1 v1 square plus half m2 v2 square. Half m1 v1 square is equal to half m1 v1 square plus half m2 v2 square. So this is equation number 1, this is equation number 2, this is equation number 3. There are, why half m2 u2 square is not there? Because second body is at rest. Here there are three equations and four unknowns. What are the unknowns? Four unknowns. What are they? V1, V2, theta 1 and theta 2. Can we solve four unknowns with the help of three equations? No. If we know value of any of the four unknown, then we can find out value of the remaining three unknowns by solving these equations. By solving these equations. ഇക്വേഷൻസിനെ സോൾവ് ചെയ്തിട്ട് നമുക്ക് അൺനോൺസിന്റെ വാല്യൂ കണ്ടുപിടിക്കാം. നോട്ട് ചെയ്യുക, ഇലാസ്റ്റിക് കൊളീഷനിങ് 2 dimension. നോട്ട് ചെയ്താ? നോട്ട് ചെയ്യട്ടോ. അടുത്ത ടോപ്പിക്ക് ഇന്ന് എടുക്കാനുള്ള ടൈം ഇല്ല, അതുകൊണ്ട് ഞാനിവിടെ സ്റ്റോപ്പ് ചെയ്യാം. അപ്പോൾ ഓൾ ഓഫ് യു താങ്ക് യു. എല്ലാവർക്കും താങ്ക് യു. അടുത്ത ക്ലാസ്സിൽ നമ്മൾ വീണ്ടും കാണാം. താങ്ക് യു.